Hello, this is Captain Chaudhari in my series of videos on marine astronomical navigation. This is the third video, and in this video I'm going to talk about a very special subject, that is celestial sphere. Celestial sphere is the core of the astronomical calculations. Like, if you have to understand the astronomical calculations, you must get friendly with celestial sphere. So what is celestial sphere? So to understand the celestial sphere, let us first draw Earth. Let us assume that the Earth is made up of transparent material. Transparent material with a point source of light, extremely powerful light at the center, right? There is this equator over here and there are these meridians, right? Okay, and let us say that there is another sphere of immense size around the Earth in such a way that the center of the Earth and center of that sphere is the same point. That means the two spheres are concentric. Now when I switch on this light, the shadow of equator will fall on this giant sphere, right? And if we say this giant sphere is celestial sphere, we will call this shadow as equinoctial. Similarly, because of the light, the shadow of north and south poles, north and south geographic poles, will be called north celestial pole and south celestial pole. And the shadow of these meridians will be called celestial meridians. So this is how you may say that everything on the Earth can be projected on the celestial sphere. For projection, you have to draw a line from the center of the Earth radially outwards towards the sky. Now what we see in the sky, what is the shape you feel is of the sky? Sky appears spherical, right? You feel that it is inner concave of a sphere. The reason for that is there are numerous millions of stars in the celestial sphere, and you cannot distinguish the distance between the two stars. One of the stars may be 10 light years away and the next star might be 70 light years away, right? But you feel that they are like brothers, they are together. They are together on the same surface. And if they are together, and if all the stars they appear to be at similar distances, then similar distance from any point, radially outwards would be considered as spherical concave, as seen from inside. So that's why we feel that the sky is spherical. So let us assume that this particular sky, which you see around the Earth, don't go for the proportion. I have drawn Earth too big and sphere too small. But you assume that this sphere is of infinite size. Sometimes people say that celestial sphere is a sphere of infinite size. Sphere is finite, and infinite means you cannot measure the dimensions. So, contradictory statement, a sphere of infinite size. So this sphere is concentric with the Earth, right? And at the time of observation, you assume that everything is static. There is no heavenly body, including the Earth, making any kind of movement. Everything is stationary, as if somebody has clicked the picture. Now this celestial sphere, which is around the Earth, is so big in size that to give importance to the size of celestial sphere, we consider the entire Earth to be like a dot. Now, to give importance to the size of celestial sphere, we say that Earth is just a dot, which is the center of the celestial sphere. And everything on the Earth can be projected on the celestial sphere. Regardless of distance, all the heavenly bodies are seen on the inner concave of this celestial sphere. So we conclude that anything on the Earth's surface can be projected on the celestial sphere. The geographical north and south are projected as north celestial pole, south celestial pole. The geographical Earth's meridians are projected as celestial meridians. The equator on the Earth is projected as celestial equator or equinoctial. Now coming back on the Earth, suppose this is the Earth, here is the equator, and these are the parallels of latitude, these are the meridians. If there is an observer at 30 degrees north, If I want that observer, if I want to study that observer, if I want that observer to come in the center of picture, what can be done? If I want to get this observer in the center of picture, I will have to modify the diagram. What I will have to do is I will have to tilt the globe forward by about 30 degrees so that the observer comes in the center of the picture. So equator will go 30 degrees down and the north pole, north geographic pole, will come down by 30 degrees. So it is north pole. 30 degrees can be seen here, 30 degrees can be seen here, and the observer comes here. The parallels of latitude would appear like this, right? So the diagram gets modified. Now if I ask you, there is an observer at 30 degrees north, where he will appear on the celestial sphere. So please note one thing, that there is a point on the celestial sphere, there is a point in the sky which is a shadow of an observer on the sky. So can we say that the celestial sphere can be understood as the projection of Earth in the sky? Everything on the Earth can be projected on the sky, and even the observer is projected as observer's zenith. If I draw the picture of the Earth, and if I draw the observer in such a way that he appears in the highest part of the Earth, observer is not on top of the pole. I have taken a picture in such a way that he appears in the highest part. So if he is in the highest part, and if I say this is the celestial sphere, can I say that this point is observer's zenith? And also can I say that this is the observer's rational horizon? So observer's rational horizon is a great circle on celestial sphere whose every point is 90 degrees away from observer's zenith. So we are looking at the picture in this fashion, that the observer appears in the highest point. Now the thing is, for any astronomical observation, for example, if you want to look at the star, if you want to take the altitude of the star, you should be taking the altitude from the center of the Earth. So this is the altitude of the star, right? You have to assume that the Earth is made up of transparent material and it is possible to take observations from the center of the Earth. Little difficult to imagine. So I would suggest that instead of imagining like this, I have an alternative. You take the camera and go in the space and try to go at a point even beyond the observer's zenith. In the sky, you go beyond the observer's zenith and you take a picture. You take a picture of the celestial sphere. So from top, what you will be able to see is a dome. You'll be able to see a dome, and the center of the dome, you will find the observer's zenith. So that is how you will find a celestial sphere, from top of the observer's zenith. Basically, you are doing the astronomical calculations considering that the observations are made at the center of the Earth, but similar calculations can be done if you assume that you are observing the celestial sphere from top of celestial sphere, from top of observer's zenith. And now I will show you how you will find the celestial sphere when you see the celestial sphere from top of the observer's zenith. So the celestial sphere will appear like this, and this outline which you see is actually observer's rational horizon, right? So this is the celestial sphere which is cut in the plane of observer's rational horizon. And as I told you, in this diagram you can say that this is west, this is east, and this is north, this is south. I'm talking about the directions: west, east, north, south. And directly below the observer's zenith, you are able to see the observer. This is observer's zenith. And I told you in my previous discussion that if I want to see the observer in the center of picture and he is in 30 degrees north latitude, I need to take the equator down by 30 degrees. If I want to see the observer in 30 degrees south in the center of picture, I will have to take the equator to the north. So by the same principle, because the observer's zenith is the shadow of observer and equinoctial is the shadow of equator, if I say that this observer on the Earth is in 30 degrees north, I can draw the equinoctial this way so that the equinoctial is 30 degrees south of observer's zenith and the measure can be 10, 20, 30. Similarly, this is the north, but north celestial pole will appear 30 degrees down from the observer's rational horizon point, right? So this is celestial sphere, and I hope you understand that we have drawn the celestial sphere in the plane of observer's rational horizon, who's standing at 30 degrees north latitude. So accordingly, if this is north celestial pole, these are the meridians and these are parallels of latitude. These are parallels of latitude. So in this video, I have explained you how we started from a transparent globe, how we projected the things on the celestial sphere, how we understood the celestial sphere as a sphere of infinite size where all the heavenly bodies are seen projected on inner concave regardless of their actual distance from the earth, right? So here what we see is the celestial sphere in the plane of observer's rational horizon, observer who's in 30 degrees north latitude.